so the derivative of a to the u equals a to the u times natural log of a times u prime. Okay, so on number 1, what is u? U is x. What is u prime? 1, dx, right? But dx is just 1. Okay, so if we want to take this derivative, we do y prime equals a to the u, so the original, 2 to the x, times the natural log of a. Well, what was a? A was 2, times u prime, which we found was 1. Okay, so y prime is 2 to the x, natural log 2. These are derivatives where the x is in the exponent. Yep, those are the notes we're doing. Okay, number 2. What is u? Meaning, what's the exponent? What's in the exponent position? 4x plus 2. U prime. Just 4. And while we're at it, let's figure out what a is. A was 5. Okay, so now we can do y prime equals the original 5 raised to the 4x plus 2 times, what comes next? Yep, natural log of 5, the base, 5, times u prime, which is 4. And you can leave it like that. Sometimes multiplying after the natural log, we don't want to confuse that. It's actually within the natural log. So you can bring the 4 in front, times 5 to the 4x plus 2 times the natural log of 5. You want to try number 3?
Yeah.
Okay, go ahead and try it. Check with your neighbor when you think you're done. See if you're getting the same thing. Now remember, pi is a constant, right? Pi is a number. You need to find the u. The u is what's in the exponent position. Then we did u prime, you take the derivative of the exponent, and then we list the a, and the a is the base. So we just make a little list down the side first. Okay, you guys done? Good. You have the same as him? Yep. Good. Yes. All right. It's looking good from the ones I've seen. Okay. Claudia, what did you get for you? Good. And u prime? Good. And a. Everyone agree? Yep. So y prime. Claudia, what do we have? The original. To the whole original. Good. Times natural log of the base, 7. Yep, and if you have it on the right-hand side, I would do parentheses so it doesn't look like subtraction. My preference is to clean it up by putting that minus 6x squared in the front. Okay. Good. Number 4, we've already learned this one by looking at the graph, but e to the x still has x in the exponent. So apply the same rule and make sure you come out with e to the x, right? Because we've already talked about the derivative of e to the x is itself e to the x. So if you apply this rule, we should prove that it does in fact come out as e to the x. Did you get it? Good. Okay. Okay, Joanna, what did you get for u? And u prime? The derivative of x. 1, and then a is the base, which is e. Okay, so we do y prime equals the original e to the x times the natural log of the base, which is e, times u prime, which is 1. What is natural log e? Just 1. It cancels each other out. So we have e to the x times 1, which is y prime equals e to the x. Okay. Number 5 looks like it has some fun stuff coming up. U, get a skinny marker. Skinny marker. Not doing skinny. Okay, what is u? Yeah, and if I could get a skinny marker, I would love to write that down. I don't know why it's not going skinny. Cosine 2x plus 1. And I heard these ladies just say it right now. How do we take the derivative? Chain rule. Okay, so the derivative of cosine is, I hope you said a negative. How about you boys over here? I hear there's a lot more people over here, so I hear more answers coming out of them. Any questions from you 4? Okay, and then we still have the same stuffing plus, or times, the derivative of 2x plus 1, which is just 2. So u prime ends up being negative 2 sine of 2x plus 1. And a is the e. Okay, so go through, apply our exponential derivative rule. When you have it, raise your hand. I'll come check. Oh, you're done. That is done. Yep. 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 Good. These all look really good, guys. Yep. Yep. Okay. Excellent. So, let's see if the board wants to cooperate this time around. Skinny marker. Okay. We should have got y prime was the original e to the cosine of 2x plus 1 times the natural log of the base times that derivative. But you guys have already told me natural log e is just 1. So times by 1 doesn't do anything, so we can take it out. E to the cosine 2x plus 1 times, some people put the e first, other people put this negative 2 sine of 2x first. We can multiply in any order with the commutative property. So there you go. So if you need to make a note for yourself, natural log of e always equals 1. If you didn't already know that. Okay, 6 and 7. I think you guys can do it. You guys are looking really good on these. Try 6 and 7. Then we'll move on to logarithmic functions with natural logs in the function we're going to take a derivative of. Joanna, I think you'll like this yellow paper too. I am. Look, someone erased the other minion. It's gone. I noticed yesterday it was gone. I was sad. How did it? Oh. Okay. Oh, that is a great question. Let's look at number 4 first. Not number 4, number 6. Not number 4. Number 4, did everyone get pi minus 4x? Now u prime, what's the derivative of pi? 0, because it's a constant. What's the derivative of negative 4x? Negative 4, dx dx, which is just negative 4. And a was the base, e. So we should have got y prime equals the original, which is e to the pi minus 4x times natural log of the base times u prime, which that is 1. So times by 1 doesn't do anything, so we can take it out. I'm going to put the negative 4 in front just because I think it looks nicer that way. E to the pi minus 4x.
E is a constant, so it's 1.
Yep, so on number 5, no, I don't know why I keep saying number 5. There's a 5 in there, but it's not number 5. It's number 7. Tricky. All these rules we've been doing is when the variable x is in the exponent. Is x in the exponent of number 7? No. Is there even an x in number 7? No. So that whole thing is a constant. What's the derivative of a constant? 0. This is a constant. So y prime is 0. So this rule, this derivative of a to the u, only applies when the exponent has the variable x in it. If e is a constant, pi is a constant. If the exponent is all constants as well, it's just 0. Okay, so watch out for that. Any questions before we move on to natural logs? Okay, Okay, logarithmic functions. Now, remember, if you remember from secondary 3, if the base isn't written as for the log, what's the base assumed to be? 10. Okay, so keep that in mind. So we have, I'm going to rewrite this because that's too small. Let me just see. Log base A of u. So just like exponential, A was the base. In log, A is the base. That derivative is something nice and long, too. I wonder if I can scoot this over. Nice. Okay, it is 1 over u times 1 over natural log of the base times u prime, which could be dy dx. Let's actually just put it as u prime here so we don't have to write that arrow every time. Okay, so number 8. Let's find our u. What is u? Use the stuffing. 2x squared plus 4x. U prime, Alex, what's u prime? Good. And A represents our base on both the exponentials and the logarithmic functions, so A is 5. Great. So, y prime equals 1 over u, so 1 over that binomial 2x squared plus 4x times the 1 over the natural log of the base times 1 over natural log 5 times u prime. And u prime was 4x plus 4, right? So you can see exponentials and logarithmics get messy really fast when you're taking the derivatives, especially if the exponent or whatever's inside the function is not just x. If it is another function itself, it gets really messy. Okay, number 9, log x squared. What's the base if it's not written? 10. Okay, would you try number 9? Yep. Good. Okay, I think we all have that one. So, on number 9, we should have y prime equals 1 over x squared times 1 over natural log of the base 10 times 2x. Okay, number 10 has natural log. But our rule here is in log form, not natural log. So any ideas? Natural log is log base e. So a few things to remember. Log of x means log base 10. Or, I guess, I wrote that wrong. Log of x, where the x is not the base, means log base 10 of x. Natural log x is log base e of x. So So those are some reminders from last year. And in this case, our variable is not x anymore, it's t. So y equals log base e of t. Okay, go through and try to do 10, 11, and probably stop there. 10 and 11. Knowing that natural log is log base e. E is a constant. When you're done with both and want to check, raise your hand. 10 and 11. Yep. Did you do both? Number 11 as well? Okay, so this simplifies a little bit. And that simplifies. What could simplify about it? Yep. Because natural log e is a number, right? Yep. Yep, those look great. Yep. 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 Those are both the same. Except for I don't think it's a squared. I think it's just a. Your 6a should be on the top, not the bottom. So at the end it's just times u prime, not 1 over u prime. So that shouldn't be a fraction, and then you'll have it right. Now, on this one, I think the base is e, not 10. So that would be a 1, and then that middle fraction will be gone. Good, 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 good. Okay, so number 10, just to review, u was t, u prime was 1, a was e. So our derivative y prime is 1 over the u, so 1 over t, times 1 over natural log of the base e, times u prime, which is 1. Natural log e, though, is what? 1. So identify that as being 1. So we get y prime equals 1 over t. So the derivative of a natural log is 1 over x. Now, if there's more than just x or just t, you're going to have a little bit of a chain in there. But if it's a simple natural log x or natural log t, it's 1 over x is the derivative, or 1 over t. Okay, for number 11, u was 3a squared minus 5. U prime was 6a. And a is e, right? Because that's log base e. So we have y prime equals 1 over 3a squared minus 5 times 1 over natural log of the base. Natural log e again is 1 times 6a. So y prime, some people combine them, which you can totally do, or you can keep them separate. Okay, or you can keep them separate as 1 over 3a squared minus 5 times 6a. Okay, look at number 12. Go and try number 12. And then I'll jump back in on number 13 because it's different. Where's your number 12? Okay, not a single person has it. It is not 0, guys. This isn't even actually a logarithmic problem. It was to throw you off. It's not exponential either. Exponential is when x is in the exponent. X is in the base. This is power rule, the very first derivative rule you learned. Well, with a little bit of chain, I guess. Power and chain rule. You have to be able to identify it because they're not going to be straightforward. Oh, this whole page is chain rule. This whole page is power rule. This whole page is quotient rule. It's going to be mixed. So don't just think, oh, because it's in logarithmic section, it's going to be a logarithmic rule. This is power rule with some chain in it. After you've done power and chain, raise your hand if you think you're ready to check if your answer's right. Well, I guess you don't have to do chain. You can treat it either way. But yeah, you can just do power as long as you remember to decrease the exponent by 1. Okay, yours is written a little different than mine, but I think it's the same. Yeah. Yep, that's better. See, that's actually easier, right? The way you've written it, you need parentheses around here and here, because both have the x root to the root 2. You also need parentheses here and here. Okay, so let's look at number 12 really quick. Power rule means we take this exponent and we bring it down as a multiplier in front, right? So y prime equals, but that binomial we need parentheses. And then times x to the exponent, but you decrease it by 1. So that means our exponent changes to root 2. So the only thing I was seeing here is we didn't have parentheses. 1 plus root 2 times x to the root 2. Okay? So the beginning exponentials was when the x was in the exponent. Logarithms was when we had a natural log or a log. Natural log is log base e, or a log. Now 13 and 14. What do you notice about 13 and 14 that we haven't seen yet today? Base x and exponent x. So these are a special case when the x is in both the base and the exponent. So the variable is the base and the exponent. Variables in both the base and the exponent. If you remember from secondary 2, how do we get the x out of the exponent? You can log both sides. Yep. So if I log both sides, log x to the x, so if we write steps, you can even do a natural log of both sides. Sometimes one's better than the other. Log both sides. Then we have a thing called the power rule with logarithms. This exponent x, where can we move it? Down in front. So we have log y equals x times log x. Okay? Then we can go ahead and take the derivative of both sides. D dx, both sides. Okay, so we've learned this log derivative today. We have two sides kind of going on. On the left-hand side, our u is y, u prime is 1, but what is the a? 10. Now, if you want to do the natural log, you could do natural log 2. You could natural log both sides, and then your base would be e. Okay, so the log 1 over what? We're taking the derivative of log y. 1 over y times 1 over natural log 10. Log or natural log?
Why do you call it log?
It's probably just me slurring my words or something.
No, not you people. It's called natural log log.
I didn't,
Yeah, they even call it log.
Oh, good call. You are so right. Good call. Okay, times u prime, which is dy dx. Now, can you see an advantage of, instead of taking the log, doing a natural log? Or is there an advantage? Now this is log base e of 10. I'll write that on this board over here. Natural log 10 is log base e of 10. If we had used the natural log instead of log, we natural log both sides, we would have gotten 1 over natural log e, which would make that 1. Okay? So instead of doing the log, let's go back through and change this to natural log. Natural log both sides. The same power rule is legal, but that will help us get natural log base is now e, and then that will cancel out. So the left-hand side just becomes 1 over y dy dx. The right-hand side, how do we take the derivative of x times natural log of x? It's product rule. Firsty last plus lasty first. First has the derivative of the last, okay? Natural log x. That should be an easy one for you to memorize. Derivative of natural log x is 1 over x. Firsty last plus last d first. Derivative of x is just 1. So we have x times 1 over x is just 1, because they cancel. 1 plus natural log x. Okay, so we're trying to find the derivative. We're trying to find y prime, or what's another form of y prime? dy dx. So we need to solve for dy dx. We're so close to being done. How do you solve for dy dx? Divide by 1 over y, or could I just times by y? If I times both sides by y, make sure you do it to everything. We get dy dx equals y times 1 plus natural log x, or you could put it through. Okay? So, step 1, natural log both sides. Step 2, derivative both sides. Step 3, solve for dy dx. Okay? One last one to do, number 14.
I must have missed y on the second side. We were doing x natural log of x. Why did we end up with natural log of x instead of 1 over natural log of x?
Because it's firsty last plus lasty first. That's not the derivative. The derivative of the first is 1. It's the product rule. Okay, one more. Notice we have an x in the base and an x in the exponent. So, follow those 3 steps. Okay, natural log both sides. Take the derivative of both sides carefully, and then solve for dy dx. Now take the derivative of the left, derivative of the right. What's the derivative of natural log y? Close. 1 over, not an x, y. But then 1 over y. But when you take the derivative of y, you also have to attach dy dx. Done? Mine's a little more complicated than that. You should have, this becomes the product rule. When you pull that down, it becomes the product rule. First, so you should still have natural logs, because first, you last plus lasty first. And everyone found a dy dx, right? When you took the natural log, or the derivative of natural log y, a dy dx should have come out of that.
Am I doing this right? So what is that rule? Just 1 over.
1 over y dy dx, because you took a derivative with the variable y. Yeah, that's going to creep up on you all the time. And then I think the right-hand side's right as long as you did the product rule. Yep. X times natural log x, which then you apply the product rule to. Here's natural log x. So now you're going to do derivatives on both sides. So what's the derivative of natural log y? Derivative of natural log y would be 1 over y dy dx. Okay, let's go through it. No, we'll go through it because we only have the bell was ringing 2 minutes early yesterday, so we're nearly out of time. Okay, so natural log both sides, I think we got to that part. Natural log x to the natural log x. The power rule of logs, we can bring that down to the front. So we get natural log x times natural log x equals natural log y. Are we all good on that part? Okay, now we do the derivative on both sides. This is going to throw you, though. It sneaks up. If you take the natural log of y, it is 1 over y dy dx. You got to watch out for that. Now we have first d last plus last d first, right? So first d last plus last d first. Aren't those like terms? How many of them are there? 2. 2 natural log x's. You can even say all over x or times 1 over x equals 1 over y dy dx. Now, I guess this is optional, but where could that 2 go? Yeah, it could be the x point. Just reverse that power rule. 1 over y dy dx equals natural log x squared times, I'm going to put the 1 over x in front. What else do we need to do? Divide by 1 over y, or an easier way so we don't deal with that fraction is times by y. Times by y to everything on the left, times by y to everything on the right. We get dy dx equals y over x natural log x squared. And y at the very, very beginning was equal to what? I guess we didn't do this on that last one. We should have done this on the last one as well. Y at the very, very beginning was equal to x natural log x. And replacing, at the very, very beginning, it said y was equal to x natural log x. So on the last problem, number 13, we should probably, step 4, plug in whatever y was equal to at the very beginning. On the last one, what was y equal to at the very beginning? X to the x. So I forgot to do that on that one. Okay, so that our equation doesn't have any just y's, because it tells you at the very beginning what y is equivalent to. Okay, so next time, 3 girls, you weren't here. Everyone has that WOTC, right? Yes? Okay, derivative test. Now, I'm not going to be collecting this. So this is just for you to go through and make sure you know how to do all these. You will have 10 random derivatives given to you on a test next time. You, similar to things on this sheet. Okay. So by Thanksgiving, you should have 100% on this derivative test. You can retake it and retake it. I only have so many copies, though. I have 5 versions, so hopefully by 5 times you've mastered it. If you want help, you can come see me after school today or tomorrow. Yeah?